All right, so let's create a quick hello world file. This is the only thing that's similar than that I do versus a lot of other kind of programming tutorials and programming courses is you always start off with a hello world file just to get you the basics of how to print things to the screen and more importantly, how do you run these files. So you have create your example.py, name it whatever you want to .py, and go inside of this text editor. And here's what I want you to type. So I'm simply going to say print. Okay. We're going to open and close parentheses. And then we'll do quotes. And then I will type hello world. Control S to save it. So it's very important that you save pretty much every time you do something. So Control S or Command S in Mac, just to make sure everything is saved. Whenever something is not saved, you'll notice right here, if I type something, there's now a white dot. So this tells you, hey, you need to save me before running me again. Okay, so Control S. Now, there are a few different ways that we can run this. So the first way that I'm going to show you is there is a little play button here, and we're simply going to say run code. Okay, and when that happens, it does this command for me. See that? And here we have typed on the screen, hello world, right? So if I change something, it's going to be inside the parentheses, hello world, welcome to my Udemy course. Okay, Control S, run it again. Hello world, welcome to my Udemy course. You will notice something here, and we'll talk about this when I tell you about variables. Okay, but you'll notice if I'm typing in words or letters to be printed, it is always inside quotation marks. These can be single quotation marks or they can be double. So if I kind of delete this here, and a quick trick for putting anything around text is if I highlight the entire thing and I'll just press the single quote button, it puts everything in a single quote. So if I run this, see, I got an unexpected indent. So let me make sure everything's fine. Welcome, hello world, welcome to my Udemy course. Just like that. Okay, this is why the indentation was really important. So you take a really quick look at this rainbow indentation. Boop, boop, boop. It changes colors. You can kind of see it. It's not too bright because it doesn't. If it was too bright, then it would be distracting from what you're doing. Okay. All right. So that's the last thing for this video. In the next video, we're going to look at how we interact with our programs. Let's start being able to place input into our programs so that we can know how the heck we break things and how we prevent them from being broken. All right, everybody. So in this video, I'm going to show you how to interact with your program or how to allow interactivity in your Python applications. Really quick before we get there, you'll notice that I have a bunch of garbage in here from running the Python programs over and over. There are a couple of things you can do, but one thing that I recommend doing is you go here where it says the output, and you can just right click and just say clear output if you kind of want to clear things up. You can also hover your cursor over here and you'll get these up and down arrows, and you can move this up and down if you need a larger display. Okay. So what are we going to do? How are we going to provide interactivity, right? So print displays something. It displays text and other things we will talk about later. Okay? Now, this makes sense, print, right? But believe it or not, it's just as simple. It's just as simple if we want to take some input. Okay. So let's say input. Okay. Please type your name. Okay. And I Control S and I'm going to go up here. Now here's something tricky. Whenever you're doing input, you can't just press this play button. It won't work properly. So click this down arrow and say run Python file. Not run code, run Python file. And now I am able to type things in here. Okay. So really quickly, I'll do the same thing again. By typing the up arrow and then pressing enter, it will just redo that same command. Okay, so please type your name. You see I'm getting a prompt, and then you can type in here, and whenever you press enter, it will save it if you save it in a variable, which we will do in the next video. So here's how this is working. It's basically an instruction for the computer. Hey, by the way, I want some input. but this is going to be my prompt for the user. This is what they are going to see. And we'll see shortly that in the next video, we're going to take whatever they type in here before they press enter, and we're going to be able to do a lot with that. So stay tuned for that. All right, so now we're able to get input. However, what are we supposed to do with that? Okay, so I'm going to quickly show you a couple of ways that we can save things in as variables. Okay, the first thing to go over is what is a variable, right? A variable is just a way of saving something in the computer's memory. All right. So the same way that maybe some of you might have hated algebra, where variable x could equal anything. It's the same thing here, except we get to give them names. All right. So if I wanted to say first underscore name, I could have that equal to my first name, right? And I told you that letters and words have to be in quotes. This is known as a string. Okay, I'm going to type a comment in here. You can comment by typing the pound symbol or hashtag symbol, the number sign, and then typing text. Okay, this will be comments are basically things you can put in your code, and the interpreter will just completely ignore them. These are like you making notes and prompts for other people reading your code to be able to understand what is going on when they go back in later. So I'm going to comment in here. This is a string. Okay. And so we have a string type variable, which is anything with quotes. And again, this can be double quotes as well. It does not matter. And I will just have age equals, let's say I'm 102. Okay. Notice how this is not in strings, right? This is not a string. This is a number. Okay. This is a number. Now, this is as far as I'm going to go for now. But what I will tell you is we're going to refer to this as an integer or int. So this is an int data type. So these are different types of data. One is a string, one is an int. For now, this is all we're going to deal with, okay? So here's what we can do. All I'm doing, let me explain this really quickly. I'm setting a variable name, right? This can be anything, okay? This can be chicken salad. It doesn't matter what this is, okay? You can name this whatever you want. It can't be numbers, and it has to start with letters, I believe. There are rules behind this, so however you see me type in variables in here, it's going to be just fine. So just follow my lead with that. But this is very simple. In other programming languages, this is a lot more difficult and complex. But it's just the name of the variable equals a single equal sign and some kind of value. Okay? Everybody with me so far? So let's continue. Now, I told you that we would be able to have input here, and we would save this input. So pause the video for a second and think about how might you do this. Okay? So let's say I just said right here, please type your name. Okay. So I'm going to simply put, okay, first name equals input, please type your name. Let's get rid of all this. First name equals input, and then please type your name. All right. Now this is going to save this in memory. So if I Control S to save it, and I just simply run Python file again, down here you will see I will say Lloyd, and nothing happens, right? Because we haven't printed it out. So here's the other part to variables. Okay. From now on, first name, anytime it is referenced in the code from here down, is literally equal. It's literally the same thing as typing as putting whatever the value is here. So pause the video and say, how do you think that we can print this out? Whatever I put my name as here, right? So really quick, I'm going to clear the screen. And if you guessed print and then first name and Control S. Now wait a second, stop before we go any further. Now this looks like letters to you, doesn't it? This looks like letters and words. So why aren't we putting this inside of the quotes? That's the question. The answer is that this is no longer a string in and of itself. This is a variable. This is a variable. So it did all the work for me. Okay. So if I go here and I say run Python file and I say Lloyd, whoa, go down here, Lloyd, enter, it says Lloyd right here. So it printed this out. So this is how you can print things out. Now, if I said age equals input and then parentheses, and I'll say, how old are you? Okay. Maybe I can do this. Control S, and then I can also print age right here. Okay. Again, over here, run Python file, and I'll say Lloyd, and it says, how old are you? I'll say 67. Now it has printed these out. Lloyd 67, right? First name, age. So that's the basics of variables. I know this was kind of a longer video, but this is a very important concept. I do recommend that you practice as much as you can. Kind of take what you've done here and see if you can come up with write your own kind of program where you kind of print things out. I'll go over more advanced ways of printing things out in another video so that we can type strings together with these variables. All right, so welcome to the F strings video. Basically, in this video, I'm going to just tell you how we can type a greeting, for instance, or type multiple variables together. So let's do this. So we already know we can print out variables, but how would I print out something like hello and then first name? Okay, there are two different ways to do this. I'm going to show you both of them. The first of which, if I wanted to just print out hello Lloyd, right? This is how I would do it. It's going to be print a string, right? Hello, and then over here we'll say a plus, and then we'll say first name. So if I do this really quick, and let me get rid of the age thing for now. So I'll run Python file, right? I'm going to say Lloyd, and here it types hello Lloyd. But you see there's a little bit of an issue here. This isn't very readable. So there's a simple way to fix this. Know that everything here is literal. You notice here how I put a space and you got this? Okay, it's the same thing here. If I want this to be all hunky-dory, I just need to put a space here. Control S. Now, if I run Python file one more time, I'm going to get what is your name? Oops, sorry about that. What is your name? Lloyd. And then it'll be hello Lloyd with a space, right? If I do the same thing again and I type in whatever I want, it will say hello, okay? Clear the screen. Now, there's a better way of doing this, folks, because what if I wanted to say, hello, Lloyd, how are you doing today? Right? Then I'm going to have to put another plus, and then another string, and then worry about another space and say, how are you doing today? Question mark, okay? Control S, I'm going to just show you this really quickly. Lloyd, goodness, I keep doing that. Lloyd, hello, Lloyd. How are you doing today? Okay. Now, what if I told you there's a better way? Okay. Let's do that really quick. There is something called an F string. And it's going to be really simple to understand here in a second. So if I wanted to do the same exact thing, I'm going to show you how similar they are. So I'm going to say print, and here's the little trick. I'm going to say F, just a single F, lowercase f, and then immediately quotes. Now I'm going to say, hello, how are you doing today? Question mark. But here I can put first name inside of curly braces. So if I said first name, I'm just putting it right here every time we have a variable. So now if I do the same thing, example, you see how both of these are exactly the same? But this, although it looks a little bit more complicated, I promise you, especially when you type less than like 80 words a minute, this is very annoying if a message gets very complex. So it's better to do this F string, and this is special functionality that is built into Python, kind of magical. And so here you can put different variables wherever you want, as long as they're in curly braces. I can do first name again. I can do commas. I can do first name again. It doesn't matter, right? Okay, first name again. I can control S. I can clear the screen, and then I can go here, run the Python file, this, and then we have all this together. It's a lot easier to put different things together. You see how I broke this twice? Like this would have been this would have been a plus sign, in between here, another plus sign in between here, and another one here, and then I don't have to worry about the spaces if I'm doing that correctly. So I hope that helped. This is how we're going to put strings together for the rest of the time. I'm going to use F strings constantly, unless it's just very, very simple. So in the next video, we are going to go over making things very, very interactive by talking about if statements. All right, everybody. So let's go over if statements really quickly. Let's get rid of this. And I'm going to give almost like an assignment with this, right? I'm going to give us a little situation. We're going to write a program that takes an age and will tell you if you are able to drive with assuming a legal driving age of 16. Okay. So the first thing we need to do is what? We're going to ask for an age, and we know that we're going to do that with the input. So let's do that really quick. Input, and then I'll say, please enter your age to continue. All right. All right. Control S to save that. And we'll just test this out really quick. The more you test your code, the better off things will be. I'm going to say 50, 45. Okay. There we go. That worked. So clear my screen. Now we need to store this in a variable. All right. So very simply put, okay, we are going to say age equals input right here. Now, here is a little nuance. This is what happens with this input. No matter what you put in here for the prompt, right? So if I'm running my Python file, regardless of whether I put a string or whether I put a number here, it will always be saved as a string. Okay? It will always be saved as a string. So if I say print and I say age plus 5, right? Watch this. If I type in 22, we get an error. You can only concatenate string, not int to string. Okay, so this is thinking that I'm concatenating, which is what we did earlier with the plus signs. Okay, so here's the thing. You can do regular arithmetic. It's just the regular. I'm not going in depth of arithmetic operators here because I don't really think it's relevant for what we want to do. And I don't know that we have time. So I'm going to run it again, say 22, it doesn't really matter. But you see here it printed out 5 plus 5, 5 plus 5. It did this automatically, 10. Okay, I know it's kind of small, 5 plus 5, 10. Now, so we would want to, now we know, since this is a string, in our if statements, we can't check this against other numbers. So there's something that we have to do. We have to convert it to an int. So that no matter what you enter, this is a string, so we have to convert it to int. So I'm going to say age equals, and then I'll just type in int, open parentheses, and age. So now this will work. So if I typed in print, and then I'll say age plus, let's say 100, okay? And I control S, clear my screen really quick, and then I'm going to run this Python file one more time. If I say 22, it answers 122. So now we know that it's working. So let's do our first conditional statement. What we're going to do is say, if the age is, let's say, if the age is over 16, then we'll print out something to the screen saying, here are your car keys. And then if it's under 16, Then we are going to print out, I'm sorry, but you can't drive. So it's going to be pretty much like I just said. We're going to say if age is less than, or excuse me, greater than 16, colon, enter. Now you see when we hit enter, it automatically indented for me here. So this is now inside of what's called a block of code. Everything in here with this indentation happens only if this condition is true, only if age is greater than 16. So what did I say I was going to do? I was going to print, here are the car keys. Okay. Control S every time. Control S, Control S. Okay. So let's go here and just run this again. I'll run the Python file. I'll say 17 for the age and hit enter. And here I have printed, here are the car keys. But if I do it again, enter your age to continue, and I say 15, then nothing happens, right? So again, this is a block of code. If I do this again, anything right here is in the block of code. Okay, got that? If I go here and I backspace, this will happen after this takes place. Okay, this is back to normal code. I said if they're older than 16, we'll print here are the car keys. Otherwise, we're going to say, sorry, but you're not old enough to drive, right? Because either you're greater than or you're less than 16, right? Okay, let's see how that works out. So there are two different ways we can do this, but the classic way is me saying else. Okay, so it's either if this, if that, if this. Otherwise, I want you to print, sorry, but I cannot let you drive. Control S. So again, let me clear the screen here, and I'll go all the way up here, and I'll run this. So press age to continue. I say 15. Whoa, not 154, 15. Hit enter. Sorry, but I cannot let you drive. If I go up again and I hit 22, it will say here are the car keys. So it's literally just checking condition. This is very English-like, isn't it? Hey, if your age is greater than 16, do this. Otherwise, or else, I want you to do this. So I just asked you the question: either you're older than 16, or you are younger than 16, right? That's correct. Okay, but that actually is not correct. This is not correct. So you could be 16. So that if you're 16, it's not greater than 16, and it's not less than 16. It is 16. So here's what we're going to do for this. In other programming languages, this is else if. Okay, this is like we're going to check multiple different conditions. So the way that I'm going to do this, the way that it's done in Python, it's a funny word. Think of else and the word else and the word if combined into an elif. Okay, and then we're going to place another condition. If the age is equal to, and here's the thing, here's the way I want you to think about it. We use double equal sign here. Okay, and I'm going to say if it's equal to 16, colon, I'm going to print out, and I'll explain the double equal sign 1 second, so don't let me lose you here. I'm just going to get this down. I'm going to say congrats for finally being, being old enough to drive, and Control S. Now, here's the equal sign. So when we set variables, we use one equal sign. Okay, so if we put an equal sign here, it would say elif, and then creating a variable. That's not going to make sense. Okay, so here's how I remember that. If I say equal to, it's it's 3 syllables, but it's 2 words. Equal to. Okay, equal to. That's how I would remember it when I was first starting out. This is checking a condition, and this is assigning signing a value. Assigning a value, checking a condition. So now we have things for all 3 different conditions. Okay. And for those of you that code in other languages and you're just wanting to learn some Python here, yes, this can be done this can be done a lot more in a more sophisticated manner, but that's beyond the scope of this short free 2-hour course. Okay. So anyway, enter your age to continue. I'm going to say 16. And I say congrats for finally being old enough to drive. This is our logic. So this is the beginning of logic. We have other things that we're going to go over like loops, but this is how we do conditions. All right, so I know this is kind of early, okay? But we're going to go over some error handling, and this is going to be part 1 of error handling. This is going to be mostly a cybersecurity lesson here. Okay? Also Python, but this is purely for cybersecurity reasons. So let's suppose for this example, we are going to enter in a number, and then we're going to print out their age plus 30, okay? Because we're printing out a program and we're going to say, let's say, uh, enter your age. We're going to say, enter your age to see how old you will be in 30 years, right? All right, this is going to be very simple. So again, if we run this, and I enter, let's say I'm 20, I get an error. Now let's talk cyber, okay? This is not what you usually see. Usually whenever you use a sophisticated program, you will see an error message, a custom error message, right? So the reason why you don't see things like this is because it's handled by the programmer. So here, I'm saying, oh, well, first of all, something is wrong here. I told you guys earlier how to fix this, and you have to convert it to int. So in the previous video, I said age equals to int age, but here you can also do this. Highlight it, shift 9 for parentheses, and come back here and do int. So this does it all in one line. This converts everything in one line, right? So that is fine and dandy, right? If I do this again and I type in 20, I get 50. So this is working normally. However, in cybersecurity, here's what you should be thinking. You should be thinking, what happens though? So I'm converting this to a string, right? What do I do? What if the user enters a string instead? Obviously, you cannot convert hello world into a number. So let's look at this really quick. If I type in some letters, well, what do you know? I get another kind of error. This is known, an error in layman's terms is known as an exception. And whenever we handle errors, we handle the exception. Okay. And here's what I tell students. Here's what I tell everyone. Okay. If you, as the programmer, do not handle the exceptions, the hacker will. Right? Because whenever there's an exception, depending on what kind of exception it is, if you have a hacker that's trying to get your program to do, basically, here's the thing. The hacker, depending on their skills, could control what happens next if you do not handle it yourself as the programmer. Okay? Maybe they want to inject code. Maybe they already injected code and they need this error to then default to another action that they have coded somehow. Okay? Or they basically for code injection, right? So again, if you don't handle the exception, a hacker will. So this is an opportunity. This is a vulnerability. This is an opportunity for a hacker to take advantage. So here's what the simplest, dumbest way you can do it, and you should never do it this way. Okay. I'm just telling you what difference this makes. Okay. Now, here's what I will say. You will put everything in a try and except clause. Let me show you what I'm talking about. I'll say try, colon. Oh, look, here's a code block. I will just paste that in here. Okay. And then here I will say except. So if an exception occurs, I will print out something went wrong. Please try again. And I'll save this. So let me get rid of this. Control X. So I'll put all of this here. So this is basically saying, hey, computer, I want you to try to do these things. And if you can't, if anything goes wrong, here's what I want you to do. So you are handling what happens with the exception. Let me show you what effects this has. Okay. If I run this and I type in letters, it says something went wrong. Please try again. There is nothing bad that has happened as a result of this. There is no opening. There's no vulnerability that an attacker could take advantage of. Now, why did I say this is the dumbest way to do it and you shouldn't? For Python, again, this is more of an advanced topic. You should think about what could go wrong and look up the names for it. Okay, so there are usually there's a list that Python has somewhere, and it is a list of exceptions. Every single exception, every error, literally has a name. Okay, so in an ideal world, you would put the name of the exception here, but we're not advanced programmers. I just wanted you to understand the concept of error handling or of exception handling. This is what we're talking about here. So we're going to try to use this in future videos whenever we're doing things with our code so that we handle the exception. All right, everybody, in this video, we're going to go over while loops. So first of all, why would we use this? There are two main kinds of loops that we're going to use in Python. One of them is a while loop and the other is a for loop. So let's suppose that you want to print numbers 1 through 1000. Okay, here's what you would do right now. Okay, you would do 1, and you could keep going here. So I can Control V, Control V, Control V, Control V. Maybe I can change this to 2. I can change this to 3, so on and so forth, right? So let me just run this really quickly, and I got 1, 2, 3, right? So here's the problem though. What if I need to like I said, what if I need to print 1 through 1000 on the screen? Okay, we're going to use a while loop for this. So I can print 1 through 1000 with maybe 3 lines of code. So there's basically 3 parts that we need. Part 1 is a counter variable. In other words, a variable that a variable that is only going to be used to count. Okay, so in this case, I'm going to say number equals 0. Okay, now the second part 2, is the while statement. And here's how this works. It's going to be while number is less than 1000. While number is less than 1000, I'm going to print number. Okay, so this is the while loop. But we need a very important third thing inside the while loop. We need to do something. This is a verb, okay? This is increment. So we need to add 1 to number. So there's 2 ways we can do this. Number equals number plus 1, or we can do a better one, which is what we'll do for the rest of this. If we can do number plus equals 1, and this will just add 1 automatically to number. And we're done. We're done. So if I run this really quickly, let me just run this. Oh, would you look at how quickly that was done? Okay. So, but here's a problem though, and this is something that I was going to explain to you in if statements, but that video was running kind of long. So To split things up, here's what you'll notice. One thing is you have to realize where you're starting from. We're starting from 0, so we printed 0 on the screen. The second thing is we stop at 999. So here's another logical operator that you need to use. First of all, we can change this to 1. Got it? And then second of all, we need to change this to greater than equal to 1000. So now it's going to include 1000. Okay, so let's run this one more time. We'll run it, and it stops at 1000, and it should start at 1. If you look right here, you can notice it started at 1. So, in other words, let's do a quick recap. So, while it basically says, hey, as long as this is true, okay, I want you to do everything inside of my code block. If you do not increment this, it will go on forever and ever, and that is very bad. Okay, you have to make sure that you increment it. In the next video, I'm going to show you a simpler way to do things, and that's going to be called a for loop. All right, so in the previous video, we went over while loops. So what I'm going to do is do the same exact thing with a for loop. Okay? Now, this is going to require the use of an extra little thing in Python. But it works kind of the same, except here's the thing. You do not need the counter variable, and you do not need the increment. So I'm going to do this in even a shorter way. So really quickly, let me get rid of all this. And I'll say for loops. And here's how we do this, folks. For, and let's call this I. We can call this whatever we want, right? We can call this number to be consistent with the previous video. For number in, and then we'll say range, okay? And this says stop, okay? Range stop. But we're going to do start and stop. It gives us the option for start and then a stop. Also a step. We're not going to worry about that. So I want to start with the number 1, right? And then I want to end with the number 1000. Okay? And then I'm going to print number. Right? So this is saying, hey, so for every number inside of the range between 1 and 1000, I want you to do this, everything inside of this code block. Okay? So let's run it. And there we go. So in 2 lines of code, we were able to print something. Oh, well, look. Well, look, 999, right? So if we go all the way to the top of this, do we start at 1? Yes. So here's something you need to know about this range. And range can be used for several different things, not just for loops. I'll keep this quick because this is not a lesson on range. We're going to primarily use for loops for other things later on down the line. But see how this is automatically done for you? So this is basically doing the dirty work for you. It's saying, oh, for number, so let's create a number, okay, variable. It creates a spot in memory, and then range, we're going to start at 1, and then we're going to end at actually 1000, which means we're not going to include this. So the second number here is what's called non-inclusive. So if we want 1 through 1000 to actually be on the screen, then we go 1001. Okay, Control S, and then we can play this one more time, and we get all the way up to 1000. So this is for loops. We're going to go over it more in detail as we use it with different types of data and for more useful applications. Lists, aka arrays. What is a list and why do we use it? First of all, a list is just a variable that stores multiple values. Okay, sounds a little complicated right now, but I'll show you how simple this is. And then what do we use it for? We use it to store multiple values. So here's one use case for it, right? So up until now, let's say that you wrote a program and it has a for loop and it asks for a name every time. Right now, you're only capable of putting those names in a single variable, and then when the next for loop comes around, that variable changes. So only the last name is saved in memory. Now, using a list, we can have a for loop asking for multiple names, and it will just add on to that list. And I'll show you how to access them in a second. So really quick, this is how you would do an empty list. So the same way you can do name equals Lloyd, you can do names equals, and boom. So square brackets is a list. And values will go in here separated by commas, okay? Any data type can be in here, or any mixture of data types can be in here. So you can have like this, and you can have false. You can have all of this inside of a list. So let's learn really quickly how to access it. So every single list has two different things. So these are the values, 1, 2, 3, KGA, KJA, SDA, K, whatever, and then false. They all have what's known as an index. So index value. And they start, you would think that, so this is 1, this is 2, this is 3, this is 4, this is 5, but that's not the case. Everything with lists start at 0. So they are 0 based. 0 based, which means this is index 0, value 1, index 1, value 2, index 3, value 3, so on and so forth. So how would we access this? First of all, let's print out the whole list to see what this looks like. And I will just do that. And we have 1, 2, 3, the whole thing is printed. If I want to just print one of these things, I will print out, let's say 0, index 0. And I will run it and I get 1 because this is at index 0. I can do 4, save it, and then I can run the application and I get false. 0, 1, 2, 3, 4, false. Okay, so what if I do this? What if I do 10 and I play? I get an error, right? Index out of range error. And so generally we don't really access these things. There are a couple of cases that I'll show you in the next video when we talk about dictionaries. But for now, just know that we can access them by their index. So how do you, let's say you wanted to print out all of these, but you don't know how many are in there. So we would just use a for loop. And there's another way. So before in a for loop, we used range, but in this, we don't need to use range. We don't need to know how many items are in this list. All we can print these out like this. I'm going to say for name in names, and then I'll say print name. So let me run this. And I have all of these things printed out, and then they are printed out one at a time. You see this? So let me explain this really quick. So before we did for I in range. So we can do, in this case, we just pat the list name, whatever the list name goes here, but we can call this whatever we want as well. Just the same way we did I. We can do N and shorten this to N. It doesn't matter, but you can see that this just makes a lot of sense. If you have a list of names, if you have a list of animals, you can say for animal in animals, right? So this is a very simple way to print things out. Now, how do we add things to the list programmatically? So I can also say, let's get rid of this for loop. Actually, let's just comment this out. Now, the way that I'm going to do this is we're going to do what I said to begin with. I'm going to make names an empty list, and we're going to have a for loop. And this for loop is going to ask for input. So I will say actually, we'll do this. We'll say while true. So this is an infinite loop, but it's not a bad infinite loop. So while true, which is, we're not changing it to false ever. What we'll do is we will say item equals input, enter a value, okay? And then we will say names.append, and then we'll say item. And actually, let's make this make a little more sense. We'll say name, and we'll say enter a name like this, and then we'll print out names every time. We'll print out names every time. So here we are just in an infinite loop asking for something, putting that at the end of a list, and then printing out the list. So I'm going to clear the screen here and I'm going to run this application. I'm going to say Lloyd, John, Cindy, um, Sandeep, right? So we have all of these names. They're added on. This can go forever and ever. Now, if I press Control C, it will just end the application like I need. So this is all you need to know about lists for now. In the next video, we'll go over dictionaries, and I'll put the both of them together, and things will start to make a little bit more sense. All right, we're going to talk about dictionaries in this video. So a dictionary, it's going to look a bit odd. It's going to look a bit strange when we do it, but you'll see how useful dictionaries are. They're very widely used. So let's get down to it. A dictionary can be simplified as two things. We're going to have a key, and we're going to have a value, right? Kind of like we have words and definitions in an actual dictionary. So we'll have a key, and we can name it whatever we want. And then we will have the value, and this is also whatever we want. So in lists, we had an index and a value, and here we have a key. So instead of accessing things by a number, we're going to access them by the name that you put in for the key. And these work in key value pairs just like this. Key value, all right? Or more importantly, key, let's just do this, right? Key value pairs. So let's do a really simple example, and I'll say person equals, and a list with square brackets, a dictionary's curly braces, and I'll say, well, what's this person's name? Okay, and I'll say it's Lloyd. If I want another item, I'm going to separate this by a comma. And I'm going to say, well, what do they do? What's their job, right? And I can say they are a mentor, okay? And then if I want something else, um, let's say age, right? I'm going to say age. We can have 50. And then if we say, let's say is employed, we will say true. See this? So we have key value pairs, and here's how we can access them. I'm gonna simply say person, right? And instead of putting numbers, again, you see as soon as I do the curly, the square brackets, all of these options pop up. So if I do is employed and I do this, there we go, right? So there we are. Now, just something that you should know before we really go any further. Okay, this is you can programmatically add things. So if I say, first of all, print out person, I'll print out the entire thing, and then I will say person, and I'll say eats. I'll say person eats cheese. Okay, equals true. Now I'll print out person again. I'll just print that out one more time, and let's run this. You see this? So we have added something to the end of the dictionary. Okay, very simple. Now let's stop being simple and let's get down to it. Okay, so we know how to access one value, but I'm going to throw you for a loop here and say, what if we have this? What if we need hobbies? Now, obviously, we can have more than one hobby. So how are we going to do this? Pause the video. Okay, we're going to do this with a list. So I'm going to say jogging, right? I'm going to say eating, and I will say something else. Don't really know. Okay, not important. So the question is, how do we access eating? How do we access eating? Well, I can simply let's print this out. I'm going to say person, right? Let's keep track. Person. Okay, now we have access to these. So I'll open this and I say, oh, look, here's hobbies. Okay, so now I have a list. Person hobbies is the list here. So now I need to I'll access jogging. So right now, this is equivalent to a list. So how do I access index 0? Well, right next to this, you just do 0. If I control S to save it and run this, I get jogging right here. Okay. If this is confusing to you, especially when you're writing your own code, there is nothing that's stopping you from going hobbies list equals person hobbies. There's nothing stopping you from doing this and then saying, okay, now this will make more sense if I go hobbies list 0. So this looks familiar to us. This makes sense to us. So you can do this to break it down at first. Eventually, you'll just get used to the fact that you can have multiple things next to each other because you can have things embedded big time. You can have a lot of things embedded because in here you can have another dictionary if you wanted, so on and so forth. Now the same thing goes, and I'm going to show you this because so that we don't have to go over this when we talk about the APIs. I want to be able to just focus on the nitty-gritty of the APIs when we get there. So the next thing I'm going to show you is, and I know this is a dictionaries talk, however, just the same way you can put a list in a dictionary, you can put another dictionary here. You can put a list of dictionaries, a dictionary of lists. You can do whatever you want. Okay. So we're going to see some of these things in the end. So it's really important to kind of practice this. However, let me take a look at the, let's take a look at this really quick. If I say people, okay, equals to, and then here's a list. I can put dictionaries in here. So I can say name, right? And then I can say Lloyd. And then if I want another one, I'll say name, right? I'll say name. Sorry, name. And I'll say Josh. And I'll do another one more, right? Because let's just do 3. And I'll say name, and I'll say, oops, not a comma, right? It's a colon. And then I am just going to say Brenda, right? So now if I print this, if I print people, if I clear the screen and I print people, I get a list of dictionaries. So how would I do this? I could simply go for person in people, and I could say print person. So now we're printing out one at a time, dictionary, dictionary, dictionary. And if I wanted to, how would I print out just their names? I would say person, and each one of these persons, each one of these people has a name, right? So I can just simply do this. And that is how you work with lists of dictionaries and a list inside of a dictionary. In the next video, we're going to talk about functions before we move on to object-oriented programming. All right, everybody, you've made it to the end of this first section here, I guess the second section, where we're going to talk about functions. So first of all, let me dispel any worry that you have and just say that you've been using functions the whole time, such as print, such as input, right? Such as list.append, right? You've been using these the entire time. So we're going to make our own. We're going to define our own functions. So the first things first is we're going to define a function that just adds 2 numbers together. And you'll see the use case for something like this whenever we get things a little bit more complicated. So here's what we're going to do. I'm going to define def a function called add and open and close parentheses, and then a colon, and then I'm inside of a code block. So now I can say, let's just print right now 5 plus 5. Okay. If I run this, nothing happens because this is just code sitting here. At no point have I told it to execute this code. This is basically just a way to organize your code, and you can use it as many times as you want later on without having to repeat yourself. Okay. So how would we do this? I'll just call it add down here. Notice this is this is no longer in the code block. This is after. Okay. So if I run it, you'll notice that there's 10 here. One really important thing to note is that order does matter. So this function has been loaded into memory before I called it. If I place this call up here above and I try to run this function, it's going to give me an error saying that add is not defined because programs are ran line by line. And here it's calling the function before it has been loaded into memory. So this is a no-no and needs to be below the function. Now, another quick thing that we should do, that I should tell you, is that generally we don't have functions that just print things out and do things. Generally, we return values. So how would we return 5 plus 5? Simple. Return 5 plus 5. Very simple, right? Now, again, if I execute this, sorry about that. If I execute this, okay, if I execute this, nothing happens because I haven't asked it to print out anything on the screen. So I can simply say print, right? So this should make sense because here's a little thing. Whenever we're returning a value in a function, this function call here is quite literally equal to whatever you return. So I can print it. I can also store this in a variable called sum. And then I can print out sum, or I can use it for some other calculation. So if I just run this, I still get 10 here. So there's all kinds of things you can do with this. Now, whenever you have used functions up until this point, you have always placed something in the parentheses, right? So if I go print something here, right? This is passing in this value, and this print function does something with it. So now we're going to be a little bit more realistic. I'm going to say a sum equals to, and actually let's back up. Let's collect, because we do interactive programs in my courses. I'm going to say that num1 equals to input, and I'm going to say enter a number, okay? And I'm going to just copy and paste this line, okay? And I'm going to say num2 equals to input, enter another number. And now we can do this. We can say sum equals to add. Now we need to place these two numbers in here. If we're going to pass two values into the function, we need to expect it on the other end. So I'm going to say num1, num2 in here, and then I will pass them in here. Num1, num2. Got it? So I'm taking inputs and I'm passing it into the function. Otherwise, you won't have access to these variables. Okay. These blocks of code, different blocks of code, depending on what it is, a function, for instance, I do not have access to any variables anywhere else in the program. That's why I have to pass these numbers in. So instead of returning 5 plus 5, I'm going to return num1 plus num2. Okay. Now let's see if this works. If I print out sum like this, really quick, clear the screen, and I'm going to run it. Enter a number, 50, enter another number, 500, and we have a problem here. Do you know what that problem is? It's treating these as strings. So we need to make sure that we have all of this set as int, right? Int. And then we're going to do the same thing here. Int. Okay. Now let's try it one more time. Enter a number, 50, 500, and then we get 550 for the sum down here. All right. So I know that was a lot. So let's go through this. One thing that might be burning in your mind right now is like, hey, what's going on? This does not have to be called the same thing as this. Okay. Because I could also pass in a number here. Okay. So if I keep it like this, that's fine. But I can say n and then n, n2. And so in here, I can refer to this as n and n2, and that's fine. So I'm passing these values in. Again, this can be whatever you want. This can be this, or these can be actual numbers, okay? So basically, and all you need to know, especially to understand object-oriented programming, is that a function, we're going to write some code. It's generally going to accept values. It does not always have to. But at the very least, we're going to return something the majority of the time, or at least we should, in order to have what is called pure functions. So we're returning this value, and we can set it equal to something, or we could have printed this out. So in the next section, we're going to go over object-oriented programming. So really practice this because you're going to need to understand how this right here works and write your own functions. But even if you don't write your own functions, you're going to need to understand that we are using functions in object-oriented programming and when we import various packages.